Hi everyone, welcome back. We continue on this and lastly we learned about normal bias classifier, and today we are gonna start to a new machine learning class which is logistic regression. Actually this is the advanced version of least square regression. In my YouTube channel you can already find the video related on the playlist of neural network. In there is a video related to least square regression. But why I'm saying this is the advanced version, we can see in the code part and also in the comparison table. So we will learn about this one. In the next video we are gonna focus the parameters. For this video we are just gonna see how this looks like. Also we will compare this with the other classes which we have already learned. Okay, this is our table, and we can go by one by about the features. Since this is just calculating according to the algorithm and giving us the weight for each class, so we can still call it parametric, and again of course it's discriminative. And speed for both training and testing is still fast, but since we are comparing with other classes, of course normal bias is the fastest one. So since using the less parameter, we cannot say this is very fast, so we are just calling them fast. Memory use still low, it's not many parameters using. Okay, and handles nonlinearity. This is important. Least square estimation only handles linear dataset. We can say logistic regression also doing the same, but this is using a sigmoid function, which is kind of not totally sharper results giving to you. What I mean, it's not directly sharpening the results. I mean, yeah, it's not okay. It's still for linear data, but advanced version, we can say. Yeah. Also this is you can maybe with linear data, I don't know, but maybe you are only thinking about the simple dataset, but not like that. Even minis dataset, if you give into this logistic regression, it's gonna give you good results, because somehow those counters of the handwritten digits, so it's still a valid data for linear optimization, linear regression, logistic regression. So also in logistic regression is used mostly in the health industry. For example, if you try to diagnose a disease, yeah, this is maybe very important. But if you do not think about the computer vision area, but just think all the parameters of a patient you are giving into the model, let's say blood or kind of different kind of values, then you are saying these are the having disease, these are do not have disease. So the model can learn it, and the new input data comes into the model. It can decide this has disease, this doesn't have disease. So yeah, this is important. Logistic regression is used in many areas. In computer vision, I also gave an example related to the minis dataset detection, which is you just also in my YouTube channel you can find the video how to detect handwritten digits. I'm putting here, you can check it. Yeah, visual intuition still is easy, but comparing KNN and the normal bias, we can call it medium. And overfitting risk also medium, because but already regularization can reduce risk, since we are easily changing the classes. Okay. Yeah, best for linearly separable data. Again, yeah, it's still needed a linear data, but yeah, I already explained. Binary classification, probability estimation. Since also this normal bias, maybe not really, but normal bias and logistic regression are both the tools for statistic area mostly. Yeah. And we can switch to the code part. I was trying to continue on this circular data which we are always using, but for this one to understand clearly I need linear data, unfortunately. So I just switch it to this one. And what I'm here, do not focus this function, but anyone really interested or really want to get that data set, or they can mail me, I will send them this function, this all code. Okay, so basically it was generating the linear data. Let's see how it looks like. Okay, we can make it bigger. Oops. Yeah, like this. So I have this black and the yellow ones, and here you see we have two different data set, and the red one and the other blue ones are just showing the regions which are which classes they are belonging to, because like we did in the previous videos, we are just going one by one for each pixels, and we are deciding its decision classes, and after that we are just drawing the trained data to see how it looks like. I'm not giving a new sample input here because whatever, for example, if I give it in here, you can easily understand this is belonging to this one, so I'm not giving a input because no need for now. And the usage, as I said, just we are creating with the default parameters. Actually it has also, it is not taking it's not taking parameters in constructor, so it's not important, but we are directly training with the default parameters. What I mean is there are many parameters in its class, which is where are they? Let's check here. I mean this set learning rate, iterations, batch size, regularization, and term criteria, kind of. We are gonna talk about them in the next video. Anyway, just you see, we have a linearly separable data and it's easily separating without setting any parameters optimized. For this video, simply I just wanted to talk about this logistic regression, and in the next video we are gonna focus its parameters. Thanks for watching. See you in the next videos.